Okay, thank you for showing up at 8:40 in the morning. But this is a very important chapter, and this is the basic of all the semester and basic of finance, basically. Some of the things we will talk about, you already know from your daily life, but now we're going to put everything in structures, and now we will have everything more in, like, let's say, problem forms, like more math will start. I don't know whether it's a good thing or a bad thing for you. So basically, if you remember, we said in the very beginning, we said the notion of time value of money is very important. And we said $1 today is not the same thing with $1 tomorrow. So this is time value of money. So now let me ask you this question. Suppose that you won a lottery and you have an option. You can take the money now, or you can take the money in 5 years. So you won $100,000. You can take the money like right now, or you can wait and take the money in 5 years. Which one would you prefer? Taking the money now, or taking the money in 5 years? So who says now? Who says in 5 years? Okay, there is nothing to be uncertain about, okay? You want money. You have $100,000. Would you want to have it now? Or do you want to wait 5 years to get the money? Huh?
Why would you wait for?
Exactly. Why would you wait 5 years? Like, there's no uncertainty here. Okay, take another sip of coffee. Okay, just wake up. Well, somebody said interest? Okay. Interest, what?
Is it negative or positive?
Oh, good question. It is positive. Even the real interest rate is positive. So basically, you all prefer to take the money now, probably. Okay? And the people who are okay with waiting 5 years, they would require something. They would require an interest, right? Why would you want an interest? That interest is important because you want a reward for waiting and not to consume now, right? You can take the money now and do the consumption. And when I say consumption, the first thing that comes to my mind is clothes and shoes and stuff. No, it can be like buying a small apartment and whatever. So it's all a consumption, let's say. I know it's investment, but take it as consumption now. So instead of not taking the money now and waiting 5 years, you require some return. And interest will be your return, basically. And in interest, you will have the inflation. I know the first thing that comes to your mind is inflation, but even if there's no inflation, you still want the interest, right? Interest is not just to cover inflation. If it was the case, then real interest would be 0%. No, it's not the inflation, it's also waiting that makes you want the interest. So this is actually the time value of money. That's it. That's the basic notion. And we said $1 you have now is more valuable than $1 you would get in 10 years, the same amount of dollar. It's more valuable to have it now because you can invest, you can make investments with that money, you can do consumption with that money. So it's important for us to have the money now. So that was the time value of money part. The other part is risk and return part, which you already know very well because whenever I ask you a question, you answer it very well. So if the money that you're going to obtain is more risky, then you require a higher return, right? If you think about a riskier investment, you want higher return. Otherwise, you wouldn't invest in a risky investment. So these are the two important things. We're starting with time value of money now, and in risk and return, I think we're going to start risk and return after after the second midterm, I think, if I remember correctly. And your first midterm will be until the end of this chapter. So basically, there's the blah, blah, blah chapters, and then there are 2 accounting chapters, and then time value of money. Again, this is a really important chapter. Whenever you get lost, ask me during the class or come to my office hours, okay? It's really important for you to understand like everything we talk about in this chapter. Okay? Because then we will talk about stock valuation, bond valuation, which is based on these chapters, and we will do almost the same thing in those two chapters. So if you get lost here, you will get lost in the two chapters following. And then poof, you're lost. Okay? Okay, ask me questions. I will try to go as slow as possible. Okay, so we said people prefer to have $1 today instead of waiting because they want to consume now. And to make them wait and not to consume, you have to offer them something. So basically that interest is the reward for people for waiting. Okay? And we talk about financial intermediaries, and we said they bring people together. There are some people who wants to consume now. There are people who wants to consume later. So people who want to consume later go to the bank. They put the money in the bank, wait for the interest. And people who want to do the consumption now, they go to the bank and take the money from the bank for an interest rate as well. So these are the this is the interest idea we have in banks as well. So first we will start with present value and future value of cash flows. Present value will be the value at present now, and the future value will be the value in the future. So basically we're going to time travel the money, okay? So here, let's start with very basics. And I know in the first hour you will be like, this is so easy, this is so easy. Then hopefully you will get all A's, hopefully. But things get complicated. Not, scary complicated, but don't start sleeping just because we start with basics, okay? Don't get lost. So you have $100. The interest rate in the bank is 10%. You put your money in the bank, and you're gonna get the money. You're gonna get the money in 1 year with 10% interest. How much money you will get at the end of 1 year? $10 plus 100. So you get the interest times the money you put in the bank, which is $10, right? $100 plus times 10%, and then you're gonna get the capital. You're gonna get the ana para as well. So you have the interest and then the capital at the end of 1 year. So you're gonna get 110. Any questions here? How about in 2 years? You put your money in the bank at time 0 today, and you're gonna get the money in 2 years. How much money you're gonna get?
$20.
Huh? Oh, okay, that's interesting. You said what? $20 plus 100. Okay. Yes? 121. Thank you so much for those two answers, because you're talking about simple interest rates. He's talking about the compound interest rate. They're both right, but you're more right. In this class, we will talk about simple interest rate, I think, at the end of this chapter. But basically, how did you think? Let's take the way that you think. Why do you think $20 should be the case?
So I have 10% interest rate. Each year I get $10. This is my money that So I get $10. In the second year I get $10 each year, and plus I will get my money back.
Perfect. So she says, let me repeat because the video cannot catch your voice. So basically she said the interest is 10%. So I have $100. At the end of first year, I will get 10% of 100, which is $10. And in the second year, again, interest rate is 10%, and I will get $10 on my $100. So together, I will get $20 at the end of the second year, plus I will get my $100, my initial investment. That makes sense. How did you think?
In the first year, we got 1 time, and then 1 time will be interest in 10% again, and it will add it should add $11 more. It's about 10%, so that cumulatively it will be 1 time.
It's like music to my ears. Exactly. So what he says is, at the end of first year, I'm gonna get Ooh, no, I don't have it. At the end of the first year, I will have $110, as you just answered. But he said, I'm not touching the interest I earned. So at the end of first year, the money I have in the bank is 110. So in the second year, I'm going to get 10% on top of it. So 10% of 110 is 11. So the second year, here, imaginary year, you're going to get $11 on top of 110. So cumulatively, you will have $121. That's the difference between simple interest and compound interest. Did you catch the difference? In the simple interest, we ignore the interest. Almost you think that you're taking the interest from the bank at the end of the first year, so you still have $100 at the end of first year in your bank. So the second year, you're going to make 10 more. What he said was, what was your name? Mart. What he said was, I'm not touching the interest in the bank, so I'm making interest over interest. It's compounding. So my money will be more than the simple interest rate because I'm not touching the interest. In this class, we will always use the compound interest rate, but you should know the difference. We will talk about those later, I think at the end of the chapter. Or maybe it's here, I don't know, we will see. It's going to be a surprise for all of us. So at the end of the second year, as Mert said, we're going to have 121. Then if I put $100 and leave it in the bank for 30 years, how much money I'm going to have? So the way I calculate things are the same way. So here, at the end of the first year, I had 110. In the second year, I got 10% of 110. So I had a total of 121. Or you can write it as this, right? I had 100. Then this 100 grew by 1 plus R, 1 plus the interest rate, right? 100 times 1.1, 110. So this is 110, the money you have in the first year. And then you grew that money with 10% more, so you multiply it with 1 plus R, 1.1. So now you have 121. Did you get lost here? Remember our deal. If you get lost anytime, you were going to ask. So I see these faces, which means you got lost. Just ask me. So I will use the same sentences, repeat what I just said. So, okay, then no questions. So after 30 years, how much money I'm going to have? So now I put $100. I left the money in the bank for 30 years. So my money will grow by 1 plus R every year for 30 years. So now I have 1 plus R to the power 30. So my money will be around $17.45. So this is how you calculate the future value of what you put in the bank. Okay, you put some money in the bank, and after 1 year, 2 years, 30 years, what's this money worth? As I said, you're time traveling. So 1745 in 30 years is worth $100 today. See, I'm saying the same mirror image of things. $100 today is worth 1745 in 30 years. 1745 in 30 years is worth $100 this year. So you're just time traveling the amount of money, okay? Assuming that interest rate is 10%. Any questions here? Okay. As I said, you can do the same exercise starting from the future, coming from the present. So if I tell you, you want to have $110 in your bank account in 1 year with 10%, and if the interest rate is 10%, how much money you should put in the bank today? So I'm just changing the question. All the numbers and everything is same. So now I'm saying you want to have $110 in your bank account in 1 year. if the interest rates are 10%, how much money you should put in your bank account today, then I'm giving you the future value, which is 110, and I'm asking you the present value. So this time you're going to say, okay, if the future value is 110, and if I know that the money I put in the bank account will grow by 1 plus r, I will just divide 110 over to 1 plus r. So it will give me 100. So the same thing, if you multiply present value with 1 plus r, it will give you 110. Present value times 1 plus r will give you the future value. You can do the same thing for 2 years. If I tell you in 2 years you need to have $121 in your bank account, how much money should you put in the bank? Then you're going to do the same thing. Each year my money will grow by 1 plus r. So in the first year, 1 plus r. In the second year, 1 plus r. So let's divide 121 by 1 plus r to the power 2, because I'm going to leave the money in the bank for 2 periods. So I should just put $100 in the bank today. So this is future value and present value, the basics. So basically, we are going to use this all the time. Okay, this is the basic time value of money equation, where, let me write it here, the future value of a cash flow will be calculated as present value of this cash flow times 1 plus r. R is the interest rate, and how much periods I have to calculate present value or future value. You can rearrange this, and you can write it as this. How much cash flow do I need with r interest rate, t period of time, to have this future value? But it's as you can see, it's the same thing. We are just rearranging the terms. Now let's solve some questions. Okay, and let's see how it will work. Your job promises a one-time retirement benefit of $100,000 on the day of your retirement. You plan to work for 15 more years, and you require a return of 6% on investment. So your interest rate is 8%, sorry, and you're going to get $100,000 when you retire. The question asks, what is this benefit worth? So I want to give you like 2 minutes. At least just write down the equation, and if you have a calculator, calculate the number. Just see whether you understand the construction of the questions. That's it. So here, there are just a couple of things that we need to pay attention to. One is, what is this $100,000? Is it the future value or the present value? It's the future value. You're going to get that money when you retire in 15 years. What is R? R, interest is 8%. How many years you're going to wait to get the money? 15 years. Exactly. So when you do the calculation, one easy check is, do you think the present value of $100,000 will be more than $100,000 or less than $100,000? Should it be more or less? It should be less, right? So that's a nice way of checking your answers. So if you put, remember our bank example, if you put $100, then it grows to 110, 120, 21, blah, blah, blah. So the present value should be lower than the future value, because for future you're growing the present value with the interest rate. As long as interest rate is positive, future value should be higher. So once you know those, the only thing you need to do is put those, put this in the formula. So I have future value of $100,000. R is 6%. T is 15. So I will use this. Oh, 8. Sorry. Thank you. Okay, so present value will be equal to $100,000 over 1.08 to the power 15. So what is present value? 31 something. What does it mean? Exactly. So you're here in the job interview, you're offered a job, and this guy is telling you, oh, we're going to give you $100,000 retirement benefit, and you say, what is it worth today? Okay, in 15 years, it's $100,000, but I live in the present time, so I'm interested in the value in the present. So I say, I do this calculation. Of course, I'm assuming this, that interest rate is 8% and it's fixed forever for 15 years. It's not very realistic for economies like ours, but maybe like for US economy, interest rates don't change that much, okay? And you can actually, in the real world, you can do the calculation as well on Excel. You can have your forecasted interest rates and you can do the calculation. It's fine. But now we need to know the basics, so focus on the basics. So it's almost like you can say, okay, if I have $30,000 now with 8% interest rate, in 15 years it's going to be worth $100,000. You're time traveling this retirement benefit. Any questions here? Yes.
Adam ne yaparsa o, ben oraya adamım. Yani adam ne yapıyormuş, ne oluyormuş sonra.
He's not doing anything. Okay, I'm just okay. So you are offering me a job, and I'm just sitting here, and you say we're gonna give you $100,000 in 15 years. I'm like, okay, in 15 years I'll be blah blah years old, and like 30 years old, and then I say, okay, $100,000 in 15 years, but what is it worth today? You know, like I'm trying to figure out whether it's a good amount of money or not in today's month. So I'm saying, okay, if the interest rate is 8%, then okay, what you said is worth $31,000 today. I'm not doing anything actually. If you get confused with this idea, you can say, it's not in this question, but you can say, if I put $31,000 in the bank today with 8% interest rate, in 15 years it's going to be worth $100,000. It's not the question says though, it's just, okay, I got the double thumbs up, so I can continue. Okay, another question. Again, very simple questions, okay, for warm-up. Always ahead of the game, Tommy, at 8 years old, believes he will need $100,000 to pay for college. So Tommy is 8 years old. Halloween is approaching, so he's probably very excited about Halloween, okay? And he's a very determined kid. He thinks about college, and he will need $100,000 to pay for college, and he will go to the college at 18 years old. If he can invest at a rate of 7% per year, how much money should he ask his rich uncle GQ to give him? So again, take a few minutes and just write down basically what is asked. What is R? What is T? Whether $100,000 is future value, present value. Okay, so let's do this as well. So this time, actually, again, is $100,000 future value or present value? It's what you need in the future, so it's $100,000. What is R? 7% is the interest rate. What is T? Perfect, perfect. Tommy's 8. He will need the money when he's 18, so it depends how many years we have ahead of time. 100. So you're gonna change these. And we know that we need less than $100,000. So what's the number? 50? 50 idi? Huh. $50,400. 238. 838. 47 nereden çıktı? I forgot my calculator for some reason. Okay, I trust you. Okay. Do you have any questions here? The idea was the same. So Tommy will ask $50,000 from his uncle. He's going to put this money in the bank for 10 years with 7% interest rate. He's going to have $100,000 to pay for college. Tommy's saved. Okay. Let's continue. Oh, there's this answer here. Okay. Okay. Now, we're going to calculate something else. What rate of return will double my money? And this is important, and please write it down, and please try to calculate it, because I think, was it the place? Yeah, here people have difficulties. What rate of return will double my money if I invest for 9 years? So I'm not giving you any numerical, any numbers. So I'm just saying that I want to double my money in 9 years. How do you calculate it? You can make up some numbers, right? So you can make up any numbers basically. So you say, if I put $1 in the bank, I want this $1 to be $2 in the future, in 9 years. What is the interest rate? Now things change a little bit, right? So I want to put $1 in the bank as the present value, and then the interest I don't know, right? And I want to double my money in 9 years, so I want this $1 to be $2 in the future. Now I'm going to calculate R. So I'm using this formula basically, right? Did you understand the entries? Okay, so 2 is equal to 1 plus r to the power 9. So what am I going to do? I'm going to take 1/9 to the power of 1/9, right? So 2 to the power 1/9 will be equal to r plus 1. So r will be equal to 2 to the power 1/9 minus 1. We will also give you present value and future value tables. And from the tables, if you can determine, t and this part, then you will be able to figure out what the interest should be. But I didn't bring them now. So when you are solving, when you're doing practice questions, then you will work on it. I will bring the tables. Okay.
Can we make it general for formula? Like R equals future value to the power of 1 over t minus present value?
Yeah, you can play with the formula for sure. Actually, there is rule of 7 to 2. So what it means is, if you want to double your money in 2 years, then the interest rate you need is 7 to 2 over how many years you're going to have. 7 to 2 over 9 will give you 8. But don't memorize it. It's just a fun thing to do. Okay. And here it says the quickest way to double your money is to fold it in half and put it back in your pocket. Yes. Okay. Let's look at this as well. The same question. We already know the answer, but let's know how we can find the numerical value. How long will it take to double my money if I invest it at 8%? The same question. How long will it take to double my money if I invest it at 8%? So I'm going to put $1, and I want it to be $2. You can pick 1 million, 2 million, it doesn't matter. Okay? as long as it's double. So now I'm giving you the interest rate 8. How long it will take to double the money? So you already know the answer. What should the answer be? It should be 9. But how do we calculate it? Now we have lns and stuff. So we have the same thing. This time I know R, right? I don't know T, right? So here 2 will be equal to 108 to the power T. How am I going to solve this for T? With ln. So basically ln 2 will be equal to T times ln 108. So T will be equal to ln 2 over ln 108. Your calculators should be able to do this. Oh, in the exam, if you ask me how to, I have no idea. I don't know your calculators. The TA is not supposed to help you with that. So know your calculator before you come to the exam, because we're not offering you any technical assistance. And also, we're going to distribute tables. So hopefully, you will not need to do this anyway. OK. I wish I brought the tables. I forgot. OK. So let's look at this, and then we can take a break. Two more slides, then we are gonna take a break. If your aunt promises to give you $100 in 10 years, your aunt is gonna give you $100,000 in 10 years. If the interest rate you could earn is 5% per year, what is the promise worth in today's terms? The second question is, if the interest rate you can earn is 8%, not 5, 8%, then what is the promise worth in today's terms? So without making any calculations, tell me what you think. Which number should be higher? So the promise is worth when the interest rate is 5%, or the promise is worth when the interest rate is 8%. So the amount you're going to get from your aunt is fixed at $100. And I'm just changing the interest rate, and I'm asking you, what is the benefits worth in today's terms?
If the interest rate is 5,
Yes. Then?
the present value of the money will be higher than the 8%.
Do you agree with him? Yes, we all agree with you. Yay. OK. He's exactly right. Think about that. Again, the bank example. If I want to earn $100 in 10 years, how much money I should put in the bank? OK, just change the question. So your aunt is like a bank. OK? So if the interest rate is 5%, then the amount you should put in the bank today should be higher. Why? Interest is lower. So you're going to make less interest over time. If the interest rate is 8%, then you can put less amount of money. Since interest rate is high, you're going to earn a lot of interest anyway. So there is a negative relationship between the interest rate and present value, right? And you can see it mathematically as well. Here, future value will be fixed. And if I change the interest rate, if interest rate increases, what's going to happen to present value? If I increase this part, the denominator increases, so this should decrease. And you understood the intuition, hopefully, and you understood the mathematics behind it. And just quickly, let's calculate those numbers as well. So here, future value is 100, interest rate is 5%, and t is equal to 10. If it is the case, what is present value? I need your help. What is the present value with this? With 5% interest rate for 10 years. Birisi hesaplıyor değil mi? Kaç? 60? Doğru mu? Okay. How about if the interest rate is 8%, we expect present value to be lower. Let's see whether it is the case. With 8% interest rate and 10 years, present value will be equal to So as I expected, when the interest rate is higher, then we can, this offer's worth is less today. So that's what you can see here. Here, this is present value of $100, and these are the number of years. So if the discount rate is 0%, then of course this present value of $100 will be the same over time. But if the discount rate increases, then as you can see, present value of this $100 in the future. Okay, so this is difficult to write. The present value of $100 that you will get in 20 years will be less today. So there's a negative relationship between present value and future value. Where's the attendance? Did everybody sign? Okay, let me just count. I think there are 41 people in the class, and then we're going to take a break. You're perfect. Okay, break time, 10 minutes. Süpersiniz.